Welcome to Brain Vision.
Okay, so for this question, we can apply the energy balance equation. We have E dot in is equal to E dot out. If we expand it, we have W dot in plus M dot H1 is equal to M dot H2. So W dot in here is the power inputs from the hollow core. Okay. So and the M dot here is the mass flow rates for the cooling air, and H1 here is the initial enthalpy for the cooling air, and H2 is the final enthalpy for the cooling air. If we do some arrangement here, we have W dot in is equal to M dot times H2 minus H1. So when H2 minus H1 can be equal to Cp times T2 minus T1. Cp is the specific heat of the air at constant pressure, and we know T2 is the final temperature, T1 is the initial pressure. I'm sorry, T2 is the final temperature and T1 is the initial temperature. Okay, and if we plug in back to the equation, we have W dot in is equal to M dot times Cp times T2 minus T1. So we know M dot, which is the mass flow rate, can be equal to the density of the air times the volume flow rates, which is equal to P1 over RT1 times V dot. P1 is the inlet pressure for the cooling air, and R is the gas constant for the air. T1 is the initial temperature for the air. So now we have W dot is equal to P1 over RT1 times V dot times Cp, and then times T2 minus T1. If we do some arrangement here, we have T2 is equal to T1 plus W dot times RT1 over P1 times V dot and then times Cp. So we know the power input is 15 watts. The gas constant is about 287 joule per kilogram times Kelvin. And we know the initial temperature is 25 degrees Celsius, which is 298 Kelvin. And the initial pressure is 1 atmosphere, which is about 1.01325 times 10 to the power 5 Pascal. And the volume flow rate is about 0.8 liter per second. If we convert it to meter cube per second, it's about 0.8 times 10 to the power -3 meter cube per second. And the specific heat for the air is about 1005 joule per kilogram times Kelvin. So now let's plug in back to the equation to determine the exit temperature or the final temperature in this case, which is equal to T1 plus, which is 298 Kelvin plus 15 watts times 287 joule per kilogram times Kelvin, and then times 298 Kelvin over 1.01325 times 10 to the power 5 Pascal, and then times 0.8 times 10 to the power of -3 meters cube per second, and then times 1005 kilojoule. Not kilojoule, just joule per kilogram times Kelvin. And this will give us the final temperature for the air, or the exit temperature for the air is about 314 Kelvin. Okay, so this is the average temperature at which the air leaves the hollow core. Okay, if we convert it to degrees Celsius, it's about 314 minus 273 degrees Celsius, which is 41 degrees Celsius. And this is the answer for this question.